All right, guys. So let's start. So today's topic is Turing machine. Let's take a grammar. Let's take this grammar, this language. A to the power, 2 to the power n, and greater or equal to 0. What are the string inside this language? What is the string inside this language? So when n equal to 0, 2 to the power 0 equal to 1. So first string would be A. Second string would be AA. Third string would be AAAA. Fourth string would be AAAA. AAAA. This way it will continue. Can we have push down automata for this? Can we have a push down automata for this? What do you think?
So this is a geometric progression. So, but so করা যাবে স্যার
Geometric progression. Yes, it is a GP. Can we have a push down automata for this?
Yes, sir.
What do you think? How this could be possible? So if there is a push down automata, definitely there is a context free grammar. What is the context free grammar for this? Yes. So the thing is, it does not have any push down automata. And it does not have any context free grammar. Because initially you have 1A, then 2A, then 4A, then you have 8A. So the problem is the number of times it is increasing. That cannot be catch using any loop. It is not possible. Did you get the point?
Yes,
So what
sir.
is actually push down automata? Push down automata is nothing but finite automata plus stack. So we know what is finite automata. How can a finite automata catch infinite length string? So it is like this. Definitely it must have a loop. It must have a loop, then it will continue. So this loop is actually catching the infinite length string. So it is catching infinite length string. Here the problem is, so a loop is linear by nature. A loop is linear by nature. So it might generate +2, it might generate +4, it might generate +8. After that one, what happened? It is generating twice n, or 4n, or 8n. So this way it will continue. But in this language, the problem is the number of times you need to catch using loop, that is also increasing. So it means you have to also increase the loop. You have to also increase the loop capability. That's why it is not possible to have a finite automata. That's why there is no push down automata for this language. Did you get it? But But this one has a Turing machine. This one has a Turing machine. Why it is a Turing machine? Because Turing machine has the, for a particular position in the memory, it has some sort of branching capability. For example, for A, I'm going to do this, task 1. On the other hand, if it is blank, I'm going to do another task 2. So that's why it is possible to have a Turing machine. Okay? Did you get it? So this kind of branching capabilities in that possible to solve this problem. Okay, guys. So that's why using Turing machine you can solve this problem. Now, what is the definition of Turing machine? So let's go. Turing machine definition is very simple. It can be represented by a quintuple. What is Turing machine definition? Q, sigma, delta, Q naught, and H. Okay. So what is Q? What is Q? What is Q? Q is nothing but
Set of states.
set of states. Sigma is nothing but
Input alphabet.
input alphabet. Delta is nothing but
Transition.
transition function. Q naught is nothing but start state. H is nothing but
Halting state.
okay. So let's do. In Turing machine, Q has two special symbols. Sigma has two special symbols. A duta symbol that is must. Must. What is one? This one is this triangle. It is called startup buffer. Second one is blank. Okay, so these two symbols must be inside sigma. So delta, comma, blank must belongs to sigma. Is a must. Now, what is startup buffer? The startup buffer is like this. Let's assume I have string like this. My string is like this. Okay, so it should be stored in a buffer. A, 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 B, B. So at the very beginning of the buffer, that should have a triangle. Okay, so this is called the start symbol. At the very beginning of buffer, we are going to assume there is a triangle. Okay, any question? Any question, guys? So at the start of the buffer, we always consider a triangle. What is the specialty about the triangle? We are going to discuss later. And what is blank? Blank is like this. Let's assume I have A, B, B. So let's take this one. If I go to this cell, if I want to remove this A, what I'm going to do, instead of A, I'm going to write a blank. That means now it becomes blank, like this. Sigma A, it becomes null. So that is the specialty about blank symbol. Okay? Did you get it? Guys, any query?
Oh, sir.
Okay, now let's go to transition. How can I define the transition? Delta is something like this. Q minus H. In halting state, there is no transition. Q minus H cross sigma maps to Q cross sigma union this one, huh, two arrows. Did you get it? There are two arrows there. Now, what is arrow?
So we can
Arrow is
move
like
freely. So in this
you can
algorithm.
move freely. Good. So let's do this. So let's assume like this. Let's assume I have this buffer. So here I got a right arrow. The next step, my header is right now here. Next step, my header will be where? My header will be here. I go from second A to third A. On the other hand, if it is like this, here if I get a this symbol, currently my header is here. After performing this, I'm going to here. This is nothing but right shift. This is nothing but left shift. Okay. Now, whole Turing machine can be like this. The Turing machine might be like this. This is my Turing machine. These are the states: H, Q0, Q1, Q2. This is my buffer. Okay. Now, what happened? Let's take this. Let's take this transition. Delta is initially Q0. It gets a A. So delta is initially it's pointing to here, Q0. It's pointing to some A. Then it would go to Q1 and it makes it black. Then what will be the catch? Catch is like this. After this transition, it will go to Q1, make this A2. Okay? Did you get the point? Did you get it? Here it means it is at Q0, seeing A. After the transition, it will go to Q1 and make this A2 black. Did you get it?
Yes, sir.
Okay. Now, two special conditions. Which are always true. Number one, delta Q0, comma, triangle is nothing but Q1, comma, Q0, comma. What is the meaning of this? What is the meaning of this? বা এটাকে আরো সুন্দর করে এইভাবে লেখা যায় delta Q naught, comma, delta, comma, then. So what is the meaning of this? What is the meaning of this? Guys, please tell me, what is the meaning of this? That means like this. Let's say I'm like this. This is my Turing machine. I'm in Q naught, H, Q1, Q2. I'm at Q naught. It is pointing to here. But definitely, whenever it gets to triangle, after transition, it must go to right. That means it is the header is pointing to here. After transition, definitely it is pointing to here. Did you get it? Whenever you reach to triangle, it moves it to right. Why? Tell me. Because if there is the start of the buffer, you are getting left, and you are getting out from the buffer. So that's why there's a start from the buffer, and whenever you reach to start of the buffer, it automatically moves you to right. It automatically moves you to right. Did you get it? If you understand. Now let's go to second one. Second one is like this. Number 2. Delta Q naught, comma A, P, then B not equal to triangle. That means there will be only one triangle. At the start of the buffer, it means there is only one triangle and you cannot overwrite any symbol with triangle. Overwrite any symbol with triangle. The triangle is automatically imprinted in the buffer and you cannot actually overwrite anything with triangle.
স্যার
All right.
ফার্স্টের লাইনে কি লেখা আছে একটু বলবেন?
There is only one triangle
একদম
and
উপরে আছে।
you cannot overwrite any symbol with triangle.
স্যার ফার্স্ট লাইনটা একদম উপরে আছে পেজের টপে।
Delta Q naught A is equal to P comma B. Then B not equal to triangle.
Yes, sir.
All right.
Yes, sir.
So let's try to solve some problems. Let's do this. Draw a TM which is going to shift right until gets a blank. So what would be the Turing machine? It is something like this. So buffer, let's say A, suddenly I get a blank. So what it is going to do? starting from here, shift left, shift left, shift left, shift left, getting a blank, halt. So how can you draw this Turing machine? Yes, tell me. How can you draw a Turing machine? How many states I require?
So two.
Two. One is the start state, another one is halt state.
Halting
So
state.
let's say my sigma is like this, q naught comma h. এখানে এটা হচ্ছে start, h হচ্ছে halt. Now what would be the transition? What would be the transition? Hold on. What would be the transition?
So seeing the start buffer, sir, we will move to right.
হ্যাঁ, গুড, এক কথা বোঝা গেল। কিউ নট আমরা যদি ডেল্টা পাই তাহলে উই আর মুভিং টু রাইট, সো কিউ নট কমা রাইট, একটা ফাইন। তারপর দেন কিউ নট
So Q not
যদি
A.
আমরা এ পাই
Yes,
তাহলে
we
আমরা
will move
কিউ
to
নট মুভিং টু
right.
রাইট।
Yes.
তারপর কিউ নট আমরা যদি ব্ল্যাঙ্ক পাই তাহলে কি করব?
So halt.
We are going to halt state and keep remain there. That's it. Good, very good. This small omega is nothing but sigma union left shift and right shift. Okay, so this is the case. Good, very good. Now this one is very important. This is also called right shifter. This one has a special name. This one is called right shifter until gets blank. So these small Turing machines are very frequently used. So that's why they have their special notations. What is the notation for this? It is like this. I right shift until A is not equal to blank. This one. I right shift until A is not equal to blank. It is also written like this. R right shift not blank. So this is the right shifter until gets blank. Okay. Now let's go to another one. How about this? How about this one? Example. Draw a TM which is going to shift right as long as we get blank. So what would be the TM for this? So it is something like this. So initially, I'm in here, I right shift, I'm here, right shift, here, right shift, here, right shift, Suddenly I got here, which is not blank. I have to stop. So what would be the Turing machine for this? What would be the transition delta? How many states I require?
Sir, 2.
Again, 2. Q naught and H. So I'm at Q naught. I get a delta triangle. Sorry, I'm going to move, keep remain to Q naught, and I shift right. Right. Then I'm in Q naught. I get a blank. I'm going to still remain in Q naught and move to right. Then I'm in Q naught, getting a A. What I'm going to do? I'm going to halt in state and keep remain A. Good, very good, very good. So this one also very important. It has some special name. Right shifter, right shifter, as long as gets blank. It is like this. R and right shift as long as A equal to blank. It is also written like this. R blank. Okay, got it? Any query, guys? Now let's go to this. Draw a TM which is going to shift left until gets a blank. It is like this. Like this. Let's say I have like this. I have started from here. Then it is not blank. I move to left. It is not blank. Move to left. It is not blank. Move to left. Finally, I get a blank. I stop. I halt here. So what would be the delta for this? How many states I require? How many states I require?
Sir, 2 again.
Two again. Okay. Q naught comma H. Q naught delta. Definitely it is going to move to Q naught like shift. Then Q naught A. Sorry, আমি একটু ভুল করছি তো রাইট শিফট না এটা রাইট শিফট এটা ফাইন তারপর I'm fine. Q naught A, I'm moving to left. Q naught, I get a blank. I'm going to halt and state, keep remain blank. Did you get it?
স্যার ফার্স্ট লাইনটা বুঝি নাই স্যার কিউ নট ট্রায়াঙ্গেল কিউ নট রাইট
Because whenever I reach to here, automatically I'm going to move to the right. That is already definition of the Turing machine.
স্যার তাহলে পরে যদি কিউ নট একে দেখে স্যার তাহলে পরে তো লেফটে মুভ করবে স্যার মানে পরেরটা তো
বুঝে I don't get you. হ্যাঁ সেটা আসছি ওয়েট এত তাড়াহুড়ার কি আছে কেন এত ধৈর্য ধারণ একটু ধৈর্য ধারণ কি করা যায় না আসছি কথা বলছি প্রবলেমটা কোথায় বলবো ডোন্ট ওয়ারি বাট ইজ ইট ক্লিয়ার টু ইউ গাইস
ইয়েস স্যার
okay so this is also special shift left shifter until gets a blank left shift a not equal to blank it's also written like this So he has already pointed out the problem is like this. Let's assume something like this. Let's assume something like this. For that left shifter until gets blank, my buffer is like this. I've started from here. Then what happened? What happened? What happened? It gets the A, which is not blank, left shift. It gets the A, which is not blank, left shift. It gets the right triangle. What it is going to do?
Right
Right
shift.
shift.
Right. Again, left. Then again, right. Left, right, left, right, left, right, left, right. This way it will continue forever. Keeps moving. So this machine never terminates. The machine never terminates for this train. Okay. Left shifter never terminates. The way we have designed the left shifter, it never terminates for A. Okay. So it might happen. Turing machine might not terminate. Did you get it? Did you get it or not? For this string, that left shifter never terminates. And there is a class of problem that is called halting problem. So what is halting problem? Halting problem is like this. Given a Turing machine and a string, whether TM halt or not. So this is called halting problem. And actually, a Turing machine can never decide this problem. No solution is possible for a TM of this problem. So a Turing machine can never solve this problem, whether that machine halts or not, for a particular Turing machine. So this problem, this halting problem, is a class of undecidable a problem which cannot be solved by. Did you get it? Is there any query, guys? So halting problem is a kind of undecidable problem which cannot be solved by Turing machine. Did you get it?
Yes, sir.
Okay, sir. So this is also an important problem. Another, we know another consequence. Another problem is there, left shifter until so as long as get blank. This is also very important and it is represented. Okay. So remember this building blocks because Turing machine. So the thing is, no matter, now let's come to the point. No matter how complicated problem, I should say not problem, I should say no matter how complicated machine you can encounter, no matter this computer or any kind of nuclear reactor, anything else, those can be modeled using Turing machine. Did you get it? And whatever inside there, they might be tiny Turing machine, but as a whole, they are also working like a Turing machine. You might say, sir, it is very funny. What are you talking about? Our computer is very complicated, and the design you have given, that is so simple. How come so simple machine can perform the complicated task like computer? Yes, it is possible. It might happen my simple machine might take so much time to solve the problem by a computer, but eventually it can do that. It might require lot of many steps, but yes, it can do that. Okay, so remember, all the machines human being made so far, they are actually working as a Turing machine. Inside it, there might be tiny Turing machine, but as a whole, they are also working like a Turing machine. So that is the catch. Now see, two fundamental problems. About TM. Number one, human being. So it is already believed by many computer scientists, and there is some sort of proof that human being cannot make. It is believed by many people, but there are few people might not believe that. Human being cannot make more complicated, I should not say complicated, more efficient machine than Turing machine. That means that means whatever complicated machine you might make, you are going to add lot many buffers. You can add RAM. You can add lot many steps. You can make a very complicated design of machine. No matter, ultimately that can be converted back to a Turing machine. That means a simple Turing machine can solve that problem. You might add thousand and thousand magnetic tapes. You might add thousand and thousand RAM, but it does not matter. Ultimately, the whole thing boiled down to the simple Turing machine model. That is one proposition. And many people, maximum people believe that one. Second thing is Turing machine cannot solve all problems. We have already give you a example. For example, this for this left shifter until gets blank, if you give a string AA, then actually Turing machine, you can design a Turing machine which can say whether it actually halt or not, whether it is going to run infinite time or it is going to halt. That decision problem cannot be made by Turing machine. So there are some problems which cannot be solved by Turing machine. Those are called undecidable problems, and halting problem is the undecidable problem. Now,
Sir,
based on these 2 points, what can you say?
sir, halting প্রবলেমের জন্য স্যার ক্যান উই মেক আ টিউনিং মেশিন স্যার এটা সলভ করার জন্য
For solving halting problems, we cannot come up with any Turing machine.
উই ক্যানট কাম
So
আপ
based on these two problems, human being cannot make more efficient machine than Turing machine. First proposition, and Turing machine cannot solve all problems. Based on these two propositions, what can you say? There can be 3 grounds. Tell me, what are the grounds? Tell me, please. First ground might be very optimistic ground. That means, yes, Turing machine might be the ultimate solution, but to solve all problems, we have to come up with better algorithms. We have to use Turing machine more efficiently. That's how we can explore more broader range of the problems, and ultimately we might come to a solution of all problems. So that is the most optimistic ground. Second ground, pessimistic ground. Yay, human being is created by God or Allah or Ishwar. So that's why human being's capability is limited. That's why human being can never go beyond Turing machine. There might have some improved machine, but human being cannot invent that one. That is the limitation. Because human being is a creation, it cannot go beyond that threshold. So that is the pessimist way. Now let's go to middle ground. Middle ground is yes, right now human beings' excellence is up to Turing machine, but eventually it might happen. Human being might come up with better machine than Turing machine. Then they can solve broader class of problems. Moreover, if they improve the algorithm, they can also solve broader range of problems using Turing machine. So that is the middle ground. Now, which one you want to choose?
স্যার মিডল
মিডল গ্রাউন্ড সব মিডল হয়ে গেছে
স্যার লাস্ট সেটটা
লাস্টেরটা গুড বিলিভার বোঝা গেল ভালো বাট সেকেন্ড ফার্স্টেরটা হইলেও তো কেউ বিলিভ করতে পারে বিলিভার হইতে পারে তাই না ফার্স্ট সেকেন্ডটা হইলেও তো বিলিভার হইতে পারে যে হ্যাঁ আপ টু নাও উই আর কনস্ট্যান্ট বাট ইভেন্চুয়ালি উইল ইমপ্রুভ আওয়ারসেলফ এটা তো বিলিভের সাথে কোনো কিছু ক্ল্যাশ করে না করে নাকি
স্যার
হ্যাঁ?
অলরেডি স্যার মুরস ল যখন বলা হয়েছিল ওইটাও স্যার ডিফাইন করা হয়েছিল যে এটা জীবনে ভাঙা পসিবল না অলরেডি স্যার ভাঙা হয়েছে সো এনিথিং ইজ পসিবল
So that's why you are actually optimistic. You have taken the middle ground. You
না
have
স্যার
taken the middle
লাস্ট
ground.
ওয়ান
Last one, Moore's. What is Moore's theorem?
যে the evolution of something at a certain rate বাড়বে
I don't get you. Please explain. Explain করেন Moore's law
স্যার
টা
মানে
হচ্ছে গিয়ে Moore's law টা কি Moore's law হচ্ছে গিয়ে every year number of every year number of
Transistors will double.
ট্রানজিস্টর
transistor in a given area is going to be getting double. So it is
Yeah.
actually all about human excellence. So it is completely opposite of the
Oh,
ground you have taken. It seems that human can be infinitely excellent. Human's capability is infinite. But you have taken the third ground. That means human is limited. How come you can connect this two? Moore's law is completely opposite of constraint. It is all about the excellence of human being. Am I right? Moore's law says that human being can actually supersede anything. Human being is superhuman. It can go beyond any limit. How come you relate this with the third ground? The pessimist ground. মেয়েরা কেউ বলেন গার্লস মেয়েদের অবস্থা দেখি কথায় আছে না কান টানলে মাথা আসে তখন ওটা করতে হয় আফরোজা আক্তার
जी सर
which ground you want to take তার কখন গ্রাউন্ডে গেল এটাই জানি না আচ্ছা তারপর রানী বিন্দুবাসিনী নেই সাবরিনা জামান তৃষা নেই সুমেধা রহমান প্রভা
जी सर
কোন গ্রাউন্ড which ground you want to take
जानना सर
জানেন না শামসিলাহি ওকে
Sir.
জি স্যার
सर डाक्सिलस
বললাম যে কোন গ্রাউন্ড which ground you want to take optimistic ground pessimist ground নাকি মিডল গ্রাউন্ড ওরা বলতেছে আপনি স্যার কখন খেলার মাঠে চলে গেলেন খেলার মাঠ কোথা থেকে আসলো ওকে ইউ ক্যান টেক এনি গ্রাউন্ড ডোন্ট ওয়ারি ইট ইজ আপ টু ইউ all grounds have some valid reason okay so let's start another problem
Sir, which one are you taking?
আমি কোনটা টেক করি আমি কিন্তু যাই হোক আপনারা ভুল বুঝতে পারেন আমি কিন্তু মানে ঈশ্বর বা আল্লাহ বিশ্বাস করি আমি স্ট্রং
হ্যাঁ স্যার এটা জানি স্যার
আমি
আপনি
স্ট্রং
ফাইট
বিলিভার
আমার মন বলে
আমি স্ট্রং বিলিভার ঠিক আছে বাট আমি সবসময় বিজ্ঞানকে সায়েন্স টেকনোলজি আই অলওয়েজ কনসিডার ইট সেপারেট ফ্রম দ্য রিলিজন I never want to mix or mingle religion with science. I never liked that one because those are completely different. One is about suspicion, one is about asking question, another one is belief. So never mix these two. I just recommend you, I advise you, don't mix these two. If you mix these two, like thousand years, people's trying to mix these two. There is no outcome. So it is better to take it separately. They should be their own position. So it is better to think separately about that. So that's why I always take the middle ground. That right now it is our constraint. We cannot actually solve all the problems, all the problems, but and this is our limit right now, Turing machine. But eventually, might happen we would come up with better machines than Turing machine. Then we might solve more problems. It might happen if we come up with excellent algorithms, you can solve better problems using Turing machines. Because over optimism is not good. If you think that Turing machine is the ultimate machine and you can solve anything using Turing machine, right now we cannot solve, then you giving a vague answer. That means we don't have algorithm. So why don't you have algorithm then? So that means if you don't have algorithm right now, that definitely there might have some better machine than the Turing machine. So that's the thing. And moreover, it seems that this is especially if you look through the living animals, they seems very complicated. It seems to me they are very complicated. I don't say they are complicated, but they are completely different than the lifeless matters. They are complicated in comparison to lifeless matter. So they are completely different kind of things. I believe that. My belief. I do not want to hurt your belief. And third thing is pessimist view that yeah, we are constrained. So if we are constrained, then we are keep stopping. We are not moving further. Right now, if we have like how many? What is the population of Earth right now?
So 7 billion?
7 billion. So what happens if it becomes 10 billion? Then we keep stopping. Hey, we don't have any more resource. We cannot do anything. Then what happens? The 3-4 billion people will die out of food. Or if we have corona, yay, which is our limitation. We don't know how to solve. Then we are all going to die. So we have to try. We have to try. Okay, so please remember my position. Always think religion separately than the science. If you mix these two, it will be harmful. You cannot go. You cannot get any solution. Not religious solution. Not get any even any scientific solution. But many people is doing those things. There are a lot of quacks, lot of people, lot of mama and dadas. They try to do that things. So please don't do these things. Okay. Okay. So a lot of religion issues that are going on. So we always keep religion separate from the science. All right. So let's go to next problem. Let's try to solve this problem. Example. Copy the contents of buffer 1 to buffer 2 until gets a blank in buffer 1. So you have to draw a Turing machine for this. How can you do that one? Any idea? It is something like this. Let's assume this is buffer 1. This is buffer 2. This is buffer 1. This is buffer 2. We have like this A blank. So what we are going to do, we get the A here, we write A here. We get another A here, we write A here. We write another A here, we write A here. We get a blank here, we write a blank here, then halt. Halt. So what would be the Turing machine for this? Any idea, guys?
স্যার এটার জন্য মেমরি লাগবে না?
মেমরি তো দুটো দেওয়াই আছে, বাফার 1 আর বাফার 2. Already we have 2 buffer. Memory is already given.
আচ্ছা আচ্ছা স্যার।
Initially buffer 2 is empty. Initially this is like this. Then we fill up. How can you do that one? How can you solve this problem? Tell me. Let's assume my states in buffer 1 is QA, states in buffer 2 is QB. How can you do that one? QA not then. Take it then. QA. QA. How can we solve this problem? Simple. দুটো তো জানি। একটা হচ্ছে QA naught delta QA naught comma triangle. What would be the case? QA naught right shift. Auto. QB naught triangle QB naught right shift. Auto. তারপর delta QA naught comma A. What we are going to do? At first we have to write. So we are going to write Q B naught A একটা আর একটা হচ্ছে delta QA naught A QA naught right shift. All right, guys? Got it? Finally, I got delta QA naught blank is nothing but QB naught blank, then delta QA naught blank is nothing but halt HA blank. And finally, I have to fill up this. Q delta QB naught blank HB. All right, guys. So this is the Turing. Did you get it? Any query? কথা বলেন, কথা না বললে ভালো লাগে না।
স্যার টিউরিং মেশিনে কি ট্রানজিশন ডায়াগ্রাম ট্রানজিশন টেবিল টাকলেই ড্র হয়ে যায় স্যার?
হ্যাঁ, এই লাইন বাই লাইন এটাও লিখতে পারেন। ইউ ক্যান রাইট লাইন বাই লাইন দিস or you can draw the table. That is also fine. এটা তো ইনিশিয়ালি শুরু হলো, নেক্সট ক্লাসে দেখবেন কি করবেন। একটা হোমওয়ার্ক দিয়ে দিচ্ছি যাওয়ার আগে। এখানে তো there are two buffers. Instead of two buffers, one buffer, how can you copy? So
স্যার হোমওয়ার্কটা প্লিজ একটু স্যার পিয়াজাতে আপলোড করে দিন।
হোমওয়ার্কটা পিয়াজেতে আপলোড করে দিব।
জি স্যার।
যে এখানে ক্লাসে লিখছি, এখন দেখে না যেগুলো বড় বড় হোমওয়ার্ক দেয় ওগুলো তো আপলোড করেই দেয়। এটা একটা প্রবলেম। Copy the content of buffer just after blank. It is like this. Let's assume I have like this a blank. So after copying, it will be like this. Next class, you are going to solve this problem. You will tell me how to solve this problem. This is homework 1. I am going to give you another homework. Next class, you will tell me how to solve this problem using Turing machine. Okay. 8 2 to the power n and get equal to 0. How can we solve this problem using Turing machine? That is one homework. Second one is copy the content of buffer just after blank. So initially it is like this. After copying, it will be like this. All right. Today live.
জি স্যার।
Let's take the attendance. All right, guys. Any more questions? Anything wants to know? Anything you wants to know?
নো স্যার। স্যার আমি আপনাকে মেল করে দিচ্ছি স্যার একটু পরে। হ্যাঁ
স্যার ফাইনালের সিলেবাস কি কনটেক্সট গ্রামার থেকে স্টার্ট?
আমি কি একবার তো বলেছি
কবে আমি শুনি নাই স্যার, আরেকবার রিপিট করা যাবে?
আমি কি ফাইনালের সিলেবাস কন্টেক্সট ফ্রি গ্রামার পর্যন্ত
না,
বলেছি?
আমি জিজ্ঞেস করছি স্যার, স্টার্ট কি হচ্ছে কনটেক্সট ফ্রি থেকে নাকি তার আগে থেকে?
আফটার মিড টার্ম
আচ্ছা,
নেক্সট ক্লাসে শেষ হবে, তখন বলবো যে আপ টু দিস সিলেবাস
ওকে
এভরিথিং উইল বি কমপ্লিট। ওকে,
ওকে ওকে
থ্যাংক ইউ, বাই,
আসসালামু আলাইকুম
স্যার আরেকটা কোশ্চেন ছিল
আসসালামু
স্যার।
প্লিজ।
স্যার আমরা যে এই